using Rust. Give a warm welcome to Pietro.
Hi everyone, in this talk I'm going to shed a bit of light on how the Rust release process works and why we do it that way. As they said, I'm Pietro, I'm a member of the Rust release team and the co-lead of the infrastructure team. And I'm actually a member of other teams, but I do a lot of stuff in the project. And I think everyone is aware by now that we actually got a release out a few days ago with some feature everyone awaited for a long time. But that's not the only release. 6 weeks later, we released 1.48, which was released in September and changed a lot of code, hundreds of thousands of lines of code. And users just reported 5 regressions after the release came out. And only 2 of them broke valid code. The other ones were just performance regressions or worse error messages. 6 weeks earlier, there was another release. And this changes tens of thousands of lines of code, and we just got 3 regressions reported. And unfortunately, all of them broke valid code, but it's a very little number. And even before, we got 1.46 out in July, with just 4 regressions reported. And so, in the talk, I want to explain a bit why we do releases this fast, which creates a lot of problem for us, and how can we prevent regressions, and just get very few ones reported after the release is out. So, why do we have this release scheduled question is a bit interesting, because it's really unusual in the compiler world. I collected some stats on some of the most popular languages. While there is some efforts to shorten the release cycle, like Python recently announced that they're going to switch to a year schedule, Rust is the only compiler, except for browsers, that's sort of popular and has a 6 weeks release cycle. And in a compiler world, that's pretty fast, but there is a simple reason why we do that. We have no pressure to ship things. If a feature is not ready, we have issues, we can just delay it by a few weeks. And nobody's going to care if it's going to get stabilized today or in a month and a half. And we actually do that a lot. The most obvious example is a few weeks ago when we decided that async await wasn't ready enough to be shipped into Rust 1.38. Because turns out it wasn't actually stabilized when the beta freeze happened, and there were still blocker issues. So we will have to crash the feature and backport the stabilization, and that's something that we would love not to do. And we actually try to do longer release cycles, especially with edition. And it turns out we don't actually, it doesn't work for us. The edition came out, the stable edition came out in December, early December. And in September, we still had questions how to make the module system work. And we had a proposal in early September, which was not implemented yet. And that's what actually was released. But the proposal had no time to bake on that. Users didn't have much time to test it. And it broke a lot of our internal processes. We actually did this thing, which is something I'm not comfortable still, which we actually landed a change in the behavior of the module system directly on the beta branch 2 weeks before the stable release came out. And if we did a mistake there, we will have no way to roll it back before waiting for an next edition. And we don't even know if we are going to do our 2021 edition yet. This request broke almost all the policies we have because we don't do this. But we had to do it, because otherwise we wouldn't have been able to ship a fully working edition. And thankfully, it ended great. The 2018 edition works. I'm not aware of any huge mistakes we made. But if we actually made them, it would have been really bad, because we will have to wait a lot to fix them, and we will be stuck in 2018 edition with a broken feature set for backward compatibility reasons. So with a such fast release cycle, how can you actually prevent regressions from reaching the stable channel? And of course, the first answer is the compiler test suite, because RustC has a lot of tests. We have thousands of them that test both the compiled output, but also the error messages. And the test runs a lot. We have 60 CI builders that run for every pull request, and each builder takes like 3 to 4 hours. So we do actually a lot of testing. But that's not enough, because a test suite can't really express everything the Rust language can do. So, of course, we use the compiler to build the compiler itself. Because for every release, we use the previous one to build the compiler. Like on Nitro, we use beta, on beta, we use stable, and on stable, we use the previous stable. And that actually allows us to catch some corner cases, because the compiler code base uses a lot of unstable features, and also is a bit old, so there are a lot of quirks in it. But still, that can't actually catch everything. And we get bug reports from you all. And we get them mostly from nightly, not from beta, because people don't actually use beta, because asking our users to test beta is something we can't really do, because with such fast release cycle, you just don't have the time to test everything manually with a new compiler every 6 weeks. And languages with longer release cycles can afford to say, hey, test the new beta release, but we can. And even when we ask, people don't really do that. So we actually had an idea. Why don't we test a user's code ourselves? And this is an idea that seems really bad and seems to waste a lot of money, but it actually works, and it's Crater. Crater is a project that Brian Anderson started, and I'm now the maintainer of, which creates experiments which actually get all the source code available on Crates.io and all the Rust repositories on GitHub with a cargo lock. So if you created an Hello World repo on GitHub or an Advent of Code puzzles repository, that's actually tested for every release to catch for regressions. And for each project, we run cargo tests 2 times, one with stable and one with beta. And if the cargo test runs on beta, on stable, but fails on beta, then it's a regression. And we get a nice colorful report where we can then inspect them. This is the actual report for 1.48. And we got just 46 crates that failed. And those are regressions nobody reported before. And then the release team manually goes through each regression. If we regress a crate, I hope we didn't break any of yours. And manually checks the log and then files issue. So then the compiler team looks at the issues, fixes them, and ships the fix to you all. And 1.49 went pretty well, because this is 1.48, and we actually had 600 crates that were broken. So if we didn't have Crater, there was a good chance your project wouldn't compile anymore when you update it. And this is something that would break the trust you have in the stable channel. So we know Crater is not perfect. There are a lot of issues. We don't test any kind of proprietary code because, of course, we don't have access to your source code. But also, we only test Crates.io and GitHub and not other repositories such as GitLab, mostly because nobody got around to write scrapers from them yet. And also, not every crate can build in the sandbox environment because, of course, we have a sandbox. We can't just run every code without any protection because it turns out people on the internet are bad. And it's not really something we can scale forever in the long term, because it uses a lot of compute resources already, which thankfully are sponsored. But if the Rust usage skyrockets, we are going to reach a point where it's not economically feasible to run Crater in a timely fashion anymore. And those are real problems, but for now, it works great. It allows us to catch tens of regressions that often affect hundreds or sometimes even thousands of crates. And it's the real reason why we can afford to make such fast releases. Without it, this is my personal opinion, but I know it's shared by other members of the release team, I wouldn't be comfortable making releases every 6 weeks without Crater, because they would just be so buggy, I wouldn't use them myself. So to recap a bit, the fast release cycles that we have are allow the team not to burn out and to simply ignore deadlines. And that's great, especially for a community of volunteers, mostly volunteers. And Creator is the real reason why you can afford to do that. It's a tool that wastes a lot of money, but actually gets us great results. So unfortunately, I don't think I have time for questions, but I'm going to be around the conference today and during the Impulse days. So if you have any questions, you want to implement support for the open source repositories, reach out to me. I'm happy to talk with you all. And thanks.
Actually, you have some time for questions.
Oh, that's great.
So, yeah.
Do we have time for one question or two? Because I have actually two.
I don't actually know that.
Okay, so first question. You were hinting that maybe the edition idea wasn't such a success for us. Would you think that jeopardizes a possible 2021 edition of the language?
Like, the main issue wasn't really the edition itself, was that we actually started working on it really late. So basically, we went way over time with implementing the features. And like, granted, this is my personal opinion, it's not the official policy of the official opinion of the project. But like, if we make another edition, I want explicit phrases that we won't accept any more changes after this date and actually enforce that, because we nearly burnt out most of the team with the edition. There were people that were just for months fixing regression and fixing bugs, and that's not sustainable, especially because most of the contributors to the compiler are volunteers.
Okay, I'll ask also my second question. So the second question is, for private repository, of course, you cannot run Crater, but how would somebody who has a private repository, a private crates setup, would run Crater, or is that possible now?
I mean, someone could just test their code on beta and create bug reports if the code fails, if the code fails to compile. We have some ideas on how to create a Crater for enterprises, but like, it's just a plan, an idea, and at the moment we don't have enough development resources to actually do the implementation, test, and documentation work that such a project would require.
So that would be necessary to support Crater in a private environment?
Yeah.
Okay.
Any other questions?
A lot of crates have peculiar requirements about their environments. Can you talk about how Crater handles that? And specifically, is it possible to customize the environment in which my crates are built on Crater?
So the environment doesn't have any kind of network access for obvious security reasons. So you can't really, like you can't install the dependency yourself, but the build environment runs inside Docker. And we have these big Docker images, which is like 4 gigabytes by now, which just has a huge list of system packages installed. So like, if you know your crate doesn't work, and you can easily check with doxrs, because doxrs actually, since recently, actually uses the same build code of Crater. So like, if it builds on doxrs, it builds on Crater as well. And if it doesn't build, you can file an issue probably on doxrs is the best place. And if our Ubuntu 18.04 package is available, we are just going to install the package on the build environment, and then your package will work.
Hello, thanks for the great talk. How long does it take to run Crater on all of the crates?
Okay, so that actually varies a lot because we are making constant changes to the build environment, changing virtual machines and such. I think at the moment running cargo test on the entire ecosystem takes a week, and running cargo check, which we actually do for some pull requests that, like, if there is a pull request on the Rust repository that we know is risky, that can break code, we actually run Crater just on that pull request beforehand, and then we usually do cargo check, which is faster. It takes about 3 days. But that really varies, mostly because we make a lot of changes to the virtual machines.
Any more? Thank you. Is it possible to supply the crater run with more runners to speed up the process?
Like, I think we could, like, at the moment, we are just in a sweet spot because we have enough experiments that we fill out the servers, but we don't have any idle time. And the queue is not that long. Like, if we had more servers, then the end result is that for a bunch of time, the server is going to be idle, so we are just wasting resources. And we have actually sponsorship from corporations that actually want to also give us great agents. So if we reach a point where the queue is not sustainable anymore, we are going to actually get from them first before asking the community. And also, like, Crater is really heavy on resources. Like, the moment I think we have 24 cores and like 48 gigabytes of RAM and 4 terabytes of disk space. So like, it's not something that you can throw a small virtual machine and get meaningful results out of it.
All right. We're out of time for questions. We're going on to the next talk. Thank you.